Hi, everyone, and welcome. My name is Roderick. I'm part of the Google Cloud community team and excited to welcome you to another office hours where we're going to talk about cost optimization best practices for BigQuery. Keep in mind that today's presentation will be recorded and you'll have access to watch it again. We received a number of questions as you registered, so we'll try to get to all of the questions today, but I invite you to continue to add questions to the chat. We'll do a repost after today's event where we will look to answer all of the additional questions that came in. So without further ado, I'll shift it over to Claudio.
Hello from Brazil. I'm Atam for GCP based here in São Paulo. Thank you for joining us today as we gather to learn about customization best practices for BigQuery. The agenda for today includes a primer for BigQuery. We focus on what is most important in BQ architecture. Just to consider when talking about customization and performance, there are some fundamentals that is very important to know. Then we will go into optimizing query. We'll cover best practices for how to structure your queries and using BQ features. Some specific topics we'll cover include partitioning tables, clustering, using caching, and query building anti-patterns. The third topic is optimizing storage in BQ. We'll cover topics about choosing the right storage options, how you will save some costs and money with those options. And then at the second part of the session, we will cover the different types of resources available, such as documentation, support channels, and community forums. Uh, and finally, we'll have time for Q&A. We already have several pre-submitted questions, as Roderick mentioned, but please feel free to ask questions you may have about BQ, customization, our presentation, or any related topics. Roderick, me, and we also have here today with us Greta Abib. She's at TEM here in Brazil also. And we'll do our best to answer your questions. Okay, let's start talking about the BQ fundamentals and review concepts in the architecture points that we'll use during this session. Uh, Google BigQuery, as you already know, is a serverless, highly available, cost-effective, and scalable data warehouse designed to help you turn big data into informed business decisions. It's a fully managed petabyte scale analytics data warehouse that enables business to analyze all their data at once. Um, it's a serverless. That means that can be used to run complex queries on large data sets, and you do not need to worry about the infrastructure. BigQuery has a number of unique features that make it a powerful tool for data analysis. And some of these features include a real-time streaming, ML and geospatial for predictive analysis, and also a high-speed in-memory BI engine. I will start with one question that has been sent, was pre-submitted. The question is, many consulting firms report conflicting cost and performance benchmarks between BigQuery, Amazon Redshift, and Microsoft Azure's Synapse Analytics. When a customer asks you what be the best method to compare cost for each performance feature, which method do you suggest? I think we can approach with in two perspectives. First one, there is a reported created by Enterprise Strategy Group. If you search for ESG, Google BigQuery versus alternative cloud-based enterprise data warehouse solutions, we you will find a report that compares all the solutions available in the market. There are at least four perspectives, four groups of items that you need to compare. Number one, upfront investment, planning, and agility that is compared in this report. Second one is operational expenses. The third, improved agility, simplified enterprise data warehouse management. And the fourth one, the assumptions that ESG used in a 3-year model scenario for TCO. Then you can use this base model to adapt to your scenario, include your assumptions and your restrictions, and you can calculate how you can choose the best platform in your case. I think Roderick or Greta can help me send you the link for this report in the chat. Then you can use this as a base and also choose your hypothesis, create an experiment, and do the calculation for your scenario. Okay, so this was the first questions that we answered. Then move on with the presentation. BigQuery is a several data analytics that transitions your traditional platform for EDW to a serverless one. BQ allows your team to focus on what matters related to your business. Unique value proposition of BQ is to be a platform for analytics and insights, moving away from infrastructure. The platform takes care of resource provisioning, handling growing scale, reliability, deployment and configuration, utilization improvements, performance tuning, and monitoring. So your team can focus on analysis and insights. And to create a nice design and configuration for your BK platform, it's important to understand its architecture. Although it's a serverless, there are some important things that you should know. Let's move into the architecture advantages of BQ. BQ decouples storage and compute and allows them to scale independently on demand. These structures offer both immense flexibility and cost controls for customers because they don't need to keep their computer resources up and running all the time. Under the hood, BQ employs a vast set of multi-tenant services driven by low-level Google infrastructure. We will mention here Dremel, the Colossus, the Jupyter, and also you have the Borg that is the base for Dremel, and also the Shuffle tier. The files are actually saved at the persistence layer of BigQuery and is provided by Colossus. For compute engine, BQ uses Dremel, the query engine. Here, workers are the slots that are frequently mentioned in BQ documentation. And the slots are used to extract data from storage and perform aggregations. To increase performance, each slot works independently from one another. Instead of communicating directly with one worker with each other, they use the memory shuffle tier to store intermediate results. All this data movement is facilitated by Jupyter, our super fast Google scale network. Architecture storage is decoupled from computing. That is huge because you can independently scale components as needed. You have this BigQuery under the hood documentation here in this URL that you can see more details about that. Let's take a look at the managed storage, Colossus. Colossus has a ton of disks that lives on a ton of servers, but in such a scale that are uh, very chances that dozens of disks are going to fail each day. So the goal is to make sure that no data is lost. Colossus ensure durability by using something called erasure encoding, which break data into fragments and saves redundant pieces across a set of different disks. However, to make sure that the data is both durable and available, the data is also replicated to another availability zone in the same region that was designated when you created your data set. This means that the data is saved in a bunch of different buildings that has a different power and system and network. BQ stores data in a columnar format. This is very important that in the columnar format, not it's the like the traditional RDBMS that stores in a row approach. And internally, there's a proprietary format called capacitor. One really cool thing about the capacitor is that it uses relevant factors like data type and how data is being used to reshuffle rows and encode columns. Colossus also ensure that your data is 100% encrypted at rest and compressed. So uh, compression and encryption is included in the cost. Uh, and in the compute layer, you have the Dremel. There's a white paper about Dremel if you are interested to know about the details. Uh, Dremel turns your SQL query into an execution tree. The leaves of the tree are called slots, and they do the heavy lifting of reading the data from Colossus and doing any computation that are necessary. DreamL dynamically apportions lots to queries on as needed basis, maintaining fairness amongst multiple servers who are querying at once. A single user can get thousands of slots to run their queries. So, with this architecture in mind, the price model for BQ is divided in two big areas, the query processing and the storage. The cost of storage that you load into BigQuery. Uh, and the query processing can be in two models: on demand, pay as you go, for the number of bytes processed by each query, or a flat rate pricing when you purchase slots with which are virtual CPUs, and we'll go into the details of each one. In the next topics, we will show you the on-demand pricing, how you can optimize your queries, and also the details about flat pricing. And for storage, and we'll talk about data retention, long-term storage, avoid duplicate storage. You can use a federated data access model, streaming and insert, and also we can talk a little about backup and recovery. Okay, let's dive into query optimization. Just to give you a detail here, by default, BQ provides on-demand capacity, which can burst up to 2,000 slots, and your pricing is simply the amount of data processed. However, as your organization process more and more data, it can become necessary to purchase slots and process unlimited data with a fixed predictable cost. Commitment for flex rate starts with a minimum of 100 slots. And so you can choose flex versus monthly. Flex is you have a flat rate for a minimum of 60 seconds versus monthly versus yearly. And the longer your commitment, the deeper your discount will be. So uh, let's take a look at some best practices for query optimization. Avoid select star. This is a very common mistake. Let's take a look here. I will just stop sharing for a moment and we'll share a console. Just a second. I will share another window here. This is a very simple query. This is the star. Select star from, there are a bunch of public data sets that are available for BigQuery. This is a samples GSOLD for weather. If you run select star from BigQuery, limit 1000, you can look at here that will process 16 gigabytes when run. This is the estimation for BQ. But if you inform all the columns as BQ is a columnar database, you will have 2.34, almost one quarter of the star. So it's simple. Oh, but I want to know only the columns that we have here in this table. Okay, you can run preview for the table. The preview for when you look at the table is not charged. It's free. And let's run this query. Query completed. What is important here? The results, of course. And you can see here the execution details. Oh, query completed and execution. Oh, no. Again, okay. Execution details. Let's do a refresh here. Okay. It's not showing here, and you have execution graph preview when you can look at how the slots are used to execute this query. Let's execute this one. We have also this. We can look here, slot one, the steps for wait, read, compute, and write, because all the results are written in a persistent disk for if you need to consult again, the same one with the cache. And then you can also look at the execution graph. It's in preview, but you can see the query here, the slots. And this is a very simple, you can, for more complex queries, understand what's happening and what are the opportunities for optimization. Okay, let's go back to the slides. Stop this one and present the slides again. Okay, so query only the data you need, and you can use preview. And for using the command line, you can use the option dry run flag in the BQ command line tool to have a preview of how much it will cost. Some anti-patterns that you need to avoid. There's a link in the presentation. You need to avoid some query that are heavily skewed, a few values filter, and you need to filter your data as early as possible. And avoid joins that generate more outputs than inputs, where a cross join is required. You pre-aggregate your data, for example. Avoid human errors. Uh, With the query, you can enforce a max limits of bytes processed at a query. It's not very uncommon to hear from customers that run some jobs in BQ that consumed a lot of bytes, and they uh, asked us why uh, that happened. So you can enforce the limits. There's a question also that someone sent, that if it's possible to limit for different groups. It's not possible yet. All the limits are are per query. If you can um, define different limits for different groups, it's not possible by this time. If you cancel your query with no error, you can be charged by the bytes processed. And other feature that you can use, and very smart, is using cache. Cache, if you run the same query more than one time, the cache can be used, but it must be the same. You can leverage the use of a service account to use better the caching. This is one of the most important slides of this presentation. If you want to choose one, just one, please focus on the partition and cluster for your data. BigQuery allows you to partition your table to reduce the data that you scan. Partition table is a special table that is divided into segments. It makes it easier to manage and query your data. By dividing a large table into smaller partition, you can improve query performance, and you can control costs by reducing the number of bytes that was read by a query. You can partition big query tables by ingestion time, by date stamp, or an integer range. When you create a clustered table in a BigQuery, the table is automatically organized based on the contents of one of more columns that is the table schema. You can cluster your table for one criteria or at maximum four criteria. So when you do a select where using the date in this example, they will only scan two partitions. And if you also include a sales rep uh, criteria here, the BigQuery will only scan by alphabetical order. Then we will scan much less bytes than if it's not clustered or partitioned. This is the most important for query optimization. Model your queries and your table, and then look at your tables. What are the best criteria based on how your business require to consult your data? Moving to flat rate reservations. Flat rate is about commitment for a fixed price uh, and capacity across workloads. You can use BigQuery reservations to isolate your commit capacity across teams or departments by creating additional reservation. When you create a commit, it's only a commercial for agreement for the number of slots and number of amount of money that you commit. And a reservation is an isolated pool of resources with the added benefit of being able to take advantage of idle capacity across your entire organization. For example, you might have a total committed capacity of 1,000 slots and three workload types: data science, IoT, and BI. You can create a DS reservation with 500 slots and assign all relevant Google Cloud projects to the DS reservation. You can create an ELT reservation with 300 slots and assign projects you use for ELT workloads to the ELT reservation. And you can create a BI reservation with 200 slots and assign projects connected to the BI tools to the BI reservations. This is how the flat rate reservations works. Let's see a couple of more details about the flat rate. As I mentioned, a slot is a virtual CPU and amount of RAM and network capacity. When you provision slots, you purchase this capacity. Uh, so in BigQuery, essentially, you run all those queries in these slots. You can use the pay-as-you-go for ad hoc queries. And for scheduled, for example, you can have a batch that runs once a week or once a month, and you can hire flex slot for 60-second minimum. And after you run that batch, that just small, very this peak of processing, you can delete the flex slot. For flat rate, you can hire monthly and annual with 15% discount. So this is more efficient, this is more predictable. On demand generally uh, gives you access to a burst of 2,000 slots, and it costs, just to remember, $5 per terabyte. Okay, so you can have flex slots, 60 seconds, minutes. You can durations for hours or couple of days. You can have flex slots, and for monthly commitment or yearly commitment. As you can see, you can choose what's best based on your use case. Election season is around the corner. Oh, election season was last year in Brazil and also in the US. You can hire, if you are a media organization, is going to process huge data for a month or two. You can use monthly commitments. Yeah, for Black Friday, Cyber Monday event, you might want to use your analytics to be supercharged with flex slots. And in case where your analytics is steady, regardless of the season, you can hire an annual or commitment. Can I mix all the models? Yes. You can do commit a flex rate yearly for steady workloads, the blue ones here. For Monday reporting, you can hire a flex slot. By default, BQ provides on-demand capacity, and beyond, your price is simply the amount of data processed. However, if you need a predictable cost, you can use all those options for for flex rate. So this is a comparison of prices on demand, 2,000 slots per project. It's burstable, $5 per terabyte. You can hire commitment with a minimum of 100 slots per month. For flex rate, this is the amount of discount that you can compare. So this is some rule of thumb for how much percent you have of discounts using the flex rate, the yearly, and the monthly. And this is a graph that will help you. This is diagram shows it's that based on your use case, you can use a hybrid approach or using flex month or annual commitment based on your workload. How can I see if it's recommended to use flex slot or on demand? The slot recommender analyzes your slot usage over the past 30 days and buckets the usage data into percentiles. For example, if a project slot usage is 2,900 slot at 90 percentile, it means that project uses fewer than 2,009 slots, 900 slots. And you have performance impact of 10% and estimated saving of this one that you are seeing in this slide. So you are seeing in this image the maximum in red, the use of slot recommender. It the slot recommender, in addition, you have an API that returns this information in the form of insights. Then you can choose if you want to go into a cost optimized, and you can suffer because the if you need more slot, your queries will enter in a queue to be processed, or you need covers all existing users that you maybe you do not have savings, but you have performance. You can run for a period of 30 days or 1 week, for example, and look at your BigQuery console, what is slot recommender is giving you in the insights. Okay, let's talk a little about storage optimization. For storage optimization, the first topic I want to talk to you here is about data retention. When you delete a table or a partition, you have these options. That is the number of days after table creation. Because you have the time travel. It's important to let just a second. The number of days after table creation, the dataset level, the default table expiration. When you delete your data, it stays for consulting by the using the time travel feature, and maybe the default for your case, if you did not change, it's 7 days. A customer of mine opened a case, a support case, because they want to save costs for storage, and they deleted a huge partition, and they looked at the cost cost report, and it was not reflected. It was because of this. The table was retained by 7 days. Then after that period, the cost of storage for BQ dropped. So it's important to know what your configuration. BigQuery also, if your table or partition has not been edited for 9 days, the storage price drops by 15%. So watch out for any actions that edits your table. If you load or if you edit some partition by mistake, you can lose these benefits. For long-term archives with access frequency at most once a year, we can think about leverage code line or archival class in Google Cloud Storage. Then you have the benefits of cost of GCS. avoid duplicates copies of data. You can use federated data access and store your data in cloud storage, as I mentioned, Cloud Bigtable, Cloud Drive, Cloud SQL. That's a new feature. And this is for infrequently changed data sets or small chunks of data that use for parameters, for example. Sometimes querying can be less performant because BigQuery does not have all the metadata to optimize, and sometimes the a preview of the cost can be returned as a 0 bytes because they cannot check what is in the external table. Load the data. It's important to know that batch uploads are free, so it's a big savings unless your business required use streams inserts for real time. And let's take a look also in the disaster recovery and backup process. By default, as I mentioned, the 7-day history is tracked by BQ. I'll show you an example of query for the data travel, the time travel here. BigQuery lets you use time travel to access data stored in BQ that has been changed or deleted. You can access the data from any point within the time travel window, which covers the past 7 days by default. Time travel lets you query data that was updated or deleted, restore a table that was deleted, or restore a table that expired. When you set your storage billing model there's a preview option. Because you are billed by the use of physical bytes. There's a preview for you to be billed for the logical bytes that will not include the time travel storage. It will be in GA soon. If set your storage billing model to use logical bytes, the total storage cost you are billed for do not include the bytes used for time travel storage. You can configure the time travel window to balance storage costs with your data retention needs. You can also use table snapshots. Table snapshots are immutable versions of base tables. They only allow read operations. You must restore the table snapshot to a normal table to perform any mutations to the metadata or data. Useful for logical backups or queries beyond time travel window. Uh, and table snapshot permissions are independent of the base table. They have their own rotation period, description, and labels that are independent of the base tables. It's a low cost. You do not incur additional storage cost for table snapshots until the base table is modified or deleted. So this is a very good feature for BQ cost optimization also. Okay, I think that what I have to say about query optimization and storage optimization is all here. I just want to let you know about the information schema. All queries in information schema are free. They are not charged. And information schema has the metadata for tables to understand slot utilization across projects, jobs, and reservations. There is a public sample for daily usage reports and many other queries and dashboards and graphs, charts that you have for about optimization. And there is also a GitHub repository that includes samples of SQL queries to use or modify. Because sometimes you do not have an overall view of what's happening. This dashboard is very helpful. Some of the queries are already included in BQ administration monitoring in the GCP console. You can see a capacity summary and what are the batches, how many bytes they are consumed during the period of you selected here in the filters. This is a basic administration task that the BQ admin should execute. And we can summarize some administration overhaul here. The BQ administrator just have to keep an eye about reservation and slots for flex rate, purchase BQ slots in UI or using an automation to acquire flex slots. The system tables use the information schema in the dashboard. The admin UI, you can leverage you can see here a list of flag commitments for slots. And also you can work with your teams that use BQ, how you implement labels and policies to enable BigQuery more efficient. Okay. You have some reference here. You have a blog post about BigQuery optimization, cost optimization, and best practices. And also, there are some presentations here, a video that was presented in Google Cloud Next, a white paper, and some solutions that are related to cloud cost optimizations for BQ. Okay, Roderick, I want to ask you if you want to talk about the next sessions for TAM webinars or if you go into the Q&A.
Yeah, so thank you so much for just this richness of information. The comments have just been alive. So there's so many amazing questions have come through. So thank you all. We have a number of questions that were submitted at the time of registration. So we'll try to get through most of those in the time that we have left. But every single question that you've asked in the comment thread today, we'll make sure that we get you an answer from our team, and then we'll share those with you in the wrap-up post. There are also going to be additional sessions of this session available in Portuguese and Spanish. So if you visit the googlecloudcommunity.com, you can find information on how to register for those sessions later on this week. And so do you want to dive into some of the questions, Claudio?
Yes, let's move to the Q&A. This is the cloud community, the event feedback. Okay, Q&A. This one I answered just is there a way to run multiple selects in one query example and to go through every partition, the external table that have 50, but can I reduce, like merge every select into one somehow? For federated queries, the wildcard for suffix for table is not supported, but the BQ will respect if, for example, you have a partition table in the origin, they will use the optimization of the origin. But there it's not possible to use the wildcards for the federated queries at this moment. BigQuery's lot estimator, I showed a sample. If you have some more additional doubt about the insights, because you want to consider business requirements if some queries that you run can wait if you run out of slots, or if you need to run very fast, you can not only commit with the monthly or yearly slots, or you can use the flex rate that is you can hire for 6 seconds at the minimum. Then you should cancel the flex slot. How do we limit consumption for a specific group of users? Example, group A consume up to X terabytes per day or dollar per day, and group B a different quota. It's not possible today. If you have multiple BigQuery projects and users, you can manage costs by requesting a custom quota that specifies a limit of the amount of query data processed per day. Creating a custom quota or query data lets you control costs at the project level or at the user level. Uh, it's not possible to assign a custom quota to a specific user or service account at the moment. Why are triggers not part of BigQuery? Can you also enhance query editor with builder, ET relationship, etc.? Oh, the enhanced query editor can be a feature request for the product team. Uh, BQ is designed as a columnar data warehouse. Trigger support specific is for updates and inserts, and it could damage performance in long term. There is a architecture patterns for manipulate data outside BQ and just data in BQ in an easy way. But the request is mandatory for those operations. Cloud SQL or high throughput DB like Spanner could be a better option. And about the editor, we can redirect to our product managers. How do we optimize the storage costs of ML datasets and historical data? Besides, we discussed in slide, I think 29, you need to watch out for any actions that edits your table loading to BQ, because for long-term archives with no access, it will drop the price for 50%. But also a common architecture pattern is to move data to cloud storage and set archiving policies on buckets. If it's active data trained in BQML, then leverage expiration labels, avoid duplicate copies of data, and see, as seen in your tile in the slide 20, I think 29. Is there a dashboard for monitoring BigQuery offending queries? There is the sample dashboard that I showed to you, and also you have some information in the BigQuery administration monitoring. What's the best use case for flex slots? As seen in the presentation, think about cases where uh, you have to rapidly respond to business demands and evaluate performances, or you have to plan to business critical calendar events, Black Friday, Cyber Monday, for example, or elections or Olympics, or for example, some batches that you run once a week or once a month. Uh, this is some good summary how we can use per query flex slots or flat rate. Monday morning ETL, for example. Urgent one, time inventory analysis per query, you use on demand. And business intelligence standard is steady workloads. How to forecast BigQuery usage for new workloads? Uh, we can, for example, use a rule of thumb that can be used is to look for the entire data that will be migrated to BQ. That will give you the storage costs part. The tricky one is the queries cost, but you need to take a look at the access data. How many users, the frequency, the length of the tables used, and the number of users that will be accessing the data. And also concurrency, because there are a limit of slots. that would give you some estimate of using the calculator. You have the GCP calculator that can give you some hints and some inspiration to get an idea of how much you could be spending the first or 2 months. And also keep track of the usage in the early beginning months so you can start gathering data to have a better estimation. How do you calculate the slots before executing the query? Uh, as I showed to you, there is an execution plan that based on the amount of storage that needs to be retrieved from Colossus. BQ estimates how many workers and also how many slots will be required. Then this is the big overview of what is happening. There is a very good presentation in YouTube called Strategies for Optimizing BigQuery Queries. Uh, we can include in the maybe Greta can help me send the link for this YouTube presentation that has some more details about how this is processed with the internals, just for curiosity. But it's based uh, on the amount of storage that's required and how you will need to process and the slots that it requires for the query. How does indexing work on BigQuery? There is no create index in BigQuery, but I mentioned to you the how it create partitions and how it creates the clustering. Those are the big main concepts about indexes and query optimization. And you can also use the same presentation for optimizing queries. There are some insights, details under the hood in the YouTube presentation. And also the Dremel, the how based on Borg, it's the very differentiator how it schedules all the workers to help in the BigQuery. How can user optimize BigQuery costs while still maintaining high performance levels? Are there any best practices for organizing data which achieve better performance? Organizing, it's about partitions and clustering. And how can users optimize BigQuery costs while still maintaining high performance? Uh, you can also use the overall administration tasks that I mentioned in the last slide in the presentation session. That the BigQuery admin can look for opportunities to hire flex rate slots and also search for the most offending jobs that are taking time and demanding resource, if it's also optimized or not. And also, I have a customer that has a team of FinOps that only have the dashboard with visibility for all those teams that use BigQuery. And they are working on an automation to open a task in Jira to alert the teams that there are some queries that needs their attention. Because to schedule a session to talk to all the teams, it's not scalable for them. So they are automating in this way, looking for opportunities to optimization in the information schema and creating automatic task in Jira for the team that's responsible for that. Can you discuss any recent updates or new features added to BigQuery that can help with customization and performance? There is a very good feature that I do not mention, that is the auto-scaling. The auto-scaling for slots is that you can also hire and configure auto-scaling. You have a base number of slots that are you configure, and the maximum amount of slots that you need to use when you need more slots to process the queries. The auto-scaling is a very nice feature that we launched I think in 3 weeks ago. How can users effectively monitor their BigQuery usage? Again, the dashboard and the uh, administration for monitoring BigQuery. What type of technical skills or expertise are required to implement cost optimization strategy within BigQuery? Of course, a nice understand of the features that are available, as I mentioned, how storage works, how you use the retention period, the cost reduction for long term, and also for the BigQuery optimization, the internals. If you people can read about the Dremel also and how to partition a good strategy about the business also, because sometimes you need to balance and choose about between price and performance. A good negotiation skill also, because sometimes you need to consider the overall concurrency of all teams that are using the same project. Okay. Can you share any success stories or use cases where BigQuery customization led to significant improvements in performance and business outcomes? Um, Yes, we have an organization here inside Google Cloud that's called Professional Services Organization, PSO. They engaged with an e-commerce company, and the customer is a heavy user of BigQuery. And they, after the engagement, after the SOW executed, the customer recognized the usefulness of BigQuery optimization insights that the PSO delivered to them. And as a result, they found hundreds of orphan tables that can be archived into and led into annual savings of thousands of dollars. They also received recommendations on potential clustering partition. About 50% of their tables are not partitioned, and they also have two projects that consistently are using on demand, but they can be converted to flat rate slots with auto scaling. And they also received the recommendations to use BI Engine for dashboards for selected frequently accessed tables, which can result in cost savings. This is an example of some of recommendations and results that the professional services organizations deliver to an e-commerce customer. But when you have visibility using the dashboards and the BigQuery administration monitoring, it's very clear on what you need to put your effort, because there you can see all the peaks of bytes scanned. Okay, don't know if
Okay.
you want me to comment anything else, Roderick.
Yeah, well, it looks like we are at our time for today, but this has been a really amazing session. Thank you so much for bringing this expertise to the Google Cloud community. As mentioned earlier, today's session will be recorded. So if you joined late or you're watching this as a replay, just know that you can use the exact same link to revisit the replay. all of the questions that were shared through today's presentation and that were shared in the feed will be answered, and we'll have a wrap-up post in the Google Cloud community. So thank you again, Claudio, and thank you for Greta for helping out with the questions. We are looking forward to future sessions. Thank you all.
Thank you.